So what we will now do is fuse together the code about taking a picture and saving it to SD card and sending some messages on the Bluetooth serial. So we'll divide our code into two files, one about the main code and one about setup, where we'll put some boring stuff like GPIO pins and stuff like this. So we create a function called do boring stuff and we put all the GPIO and imports inside. So we import our setup.h file inside picture central bluetooth.ino. So now in the setup part of picture central bluetooth.ino we call our function do boring stuff from setup.h. And now let's put all the code about sending stuff through Bluetooth and create a Bluetooth serial object named serial_bt. We will take a picture when we will type P inside the terminal. We will save this picture to SD card and afterwards we will send it through Bluetooth. This will be useful to compare when the image will be received on the Android phone. Now we can add all the code to save the picture on the SD card. Quite some lines and not really necessary to understand everything. We already saw it in the first part anyways. And now let's give it a try. So the Bluetooth initialization part worked. Now let's try to take a picture by typing P. Looks like it worked. We can take a look at the SD card and everything is fine. Now let's send the picture to Bluetooth. You will see it isn't so complicated. It just takes a few lines. In fact, it is easier than saving it to the SD card. We just have to write serial_bt.write fbbuff. Actually, fbbuff contains the picture taken by the ESP32-CAM. Let's try our code. Let's launch the app we just created in part 2 from the Android Studio. Our connection was successful. Let's type just hey to see if it is working, it's okay. And now let's type P and see if we receive the picture. We are receiving it, but under the form of just strings. Of course there is some work to do to display the real picture, and this is what we will do right now. Here we will add an image view inside the XML file describing our UI. We can see an error because there is no constraint. We fix this error by adding a constraint relative to the text view, where Hello World is displayed. We can now get our image view inside the Java code. We create an image view object called IV. As usual, we instantiate our IV, our image view, with the method findViewById. And now to test our image view is working correctly, we'll just display a cool mountains picture when some messages are received through Bluetooth. We can now test our app. Let's send one test message. And as expected, the mountains picture is displayed. And if we type P, nothing has changed. We just see some random strings that don't mean anything. We will have to decode them. Before writing some code, let's do a quick recap of the data flow inside the application. We get our packet from the Bluetooth socket thanks to the method getInputStream. We then put our packet inside another input stream called mmInStream. And next we are able to convert our input stream to a byte buffer thanks to the method read. When the ESP32-CAM sends an image, he begins by writing picture arriving. We will detect this string inside ConnectedThread to get into picture reception mode. Else we are receiving text messages. When the ESP32-CAM sends the image through Bluetooth, he does it by sending packets. Generally, size of a packet is around 1024 bytes. What we will do is we will get the size of this image, count the received packets, and when the total size of all the received packets is the size of the image, for instance 100,000, we will know we finished receiving the image and we will be able to get out of the picture reception mode. So to get the size of the image, we just have to split the message and we get the second part by using the index 1. We use a byte array output stream to write the image. Each packet received, we add the size of this packet, which is numbytes, to total number of bytes, and if total number of bytes received is superior or equal to size of the image, we know we finished receiving the whole image. And now we can set read message to an empty string. This way at the next iteration we will be into the default mode, which is receiving text messages. When the transmission is finished, we can convert our image to an array of bytes. And after this, convert this array of bytes to a bitmap. Using bitmap factory to decoy byte array. And now that we have our bitmap, we can put it inside a message and send it to a handler. The only thing left to do now is to create the message for the handler. We will put arg2 to 1 to inform mainActivity that this is an image. Now inside mainActivity we will add a condition on arg2. If arg2 is equal to 1, set IV, our image view, and if arg2 isn't equal to 1, set TV, our text view. Finally, we can send to target. Now our message is ready. And last step, we don't forget to clean our object for the next picture arriving. We set size of the image to 0. We set total number of bytes received to 0. And we reset also our output stream. Let's try our code. We begin by sending a small text message. Hey, we can see it is working. Now let's try to send a picture by pressing P. And it doesn't work at all. We just have a mix of characters. This means our app is still seeing this as text messages and not as an image. So let's begin by debugging by adding some logcat messages. We will put one that says that the handler has detected a picture arriving. This way we will know if it goes into a picture receiving mode or not. So we just have a lot of message received messages. This is because I left the logcat message received at the beginning of the handler. So we need to modify this because it is printed at each packet. We are not really interested in this. We will also add a locate message getting into picture reception mode inside the ConnectedThread. And we will put the message received only when receiving text. And we also add a locate message when the transmission is done. Let's try again. So nothing has changed because we just added some logcat messages. So what do we have? We have the picture reception mode, we have the finished receiving picture, and we still receive some text messages after this. So what this means is that it goes out of the picture reception mode before the whole image is sent. So we need to debug this. So now let's try again with the debugger. We can see the size of the image was correctly sent. So we can see the total number of bytes received is 23. Let's go to the next step and we can see our total number of bytes received inside of the image went to 0. So this means our variables were reset, and this means they are not at the correct place in the code. They were reset at the next loop iteration, so we need to move them before the loop. So let's try to debug again. Now let's try again. And we still receive a text message after the image, so this is not correct. To investigate this, we will use two breakpoints, one at line 83 where the bitmap is created, and one at line 84 where we create the message for the handler. Our app is stopped line 84, and we can see that the total number of bytes received is superior to the size of the image. Of course, this is not what we want. These two numbers should be equal. This is because before sending the image, the ESP32 sends a small message, picture arriving with the size of the image. And actually what's happening is that this small message is included inside the image. To fix this, we just have to move the small code snippet detecting that this is an image arriving after the code dealing with the image packets. This way it will be considered as a text message and won't be included in the image. Let's try once more. We finally can see our image appearing on the smartphone. We can try now to send another image right after to see if our reset code is working well, and we can see it is working, a spawn has appeared. So now I will show you how to get the project from GitHub. You just need the URL of the repository from GitHub, and you copy it inside Android Studio using getFromVCS function. VCS means version control system. So Android Studio will clone everything automatically, including the code for the ESP32. You might experience some version problems with the SDK or Gradle, but theoretically Android Studio should provide all the options necessary to fix them. So as you can see, Gradle build was successful and we are now able to build and launch our application, even though we are on a completely different system. We are on Linux and everything was built on Windows. And as you can see, the folder with code files for the ESP32 was also cloned by Android Studio with everything. You just have to use the path of this folder and you can open it in the Arduino IDE, and you can see that that compiling these files into a binary for the ESP32 works without a problem if your Arduino IDE is configured as I explained in the first video. So in the end, this was a quite difficult project, as I did not know much about ESP32s or Android programming at the beginning, but thankfully, thanks to all the tutorials available online and thanks to the documentation, I was able to build something. I'm not the best programmer out there, but still I managed to create something that works. I hope you like this video. If so, you can give me a like and subscribe, as I will make more.